Greetings, everyone, for the first online session, Scientific Session 1D here in the World Resource Forum. Thanks for joining, either in Geneva or here online, wherever you are on the planet. I'm co-hosting this session together with Kei Jing from the University of South Australia. My name is Christoph Helbig from the University of Bayreuth. Kay is currently, for technical reasons, not yet joining in. We'll see whether he joins us later on. So the idea here of this session is to bring people together on a session on buildings and energy, and we'll have three presentations. We mixed up things a little bit. If you can give me the next slide, please, already. So originally, the idea was to have two different slots. We will merge this into one slot altogether. We will start with Ben's presentation on supply chain justice considerations for new energy vehicles. Veronica, we'll hope she will join us. Then we'll put her into the next part on the end. And then can you give me the slide for slot 2 as well? Okay, yeah. Then we will have Willem's presentation on catalyzing sustainability innovation in the construction industry ecosystem through intrinsic self-motivational targets. And we have both Daniel and Alejandra here who will talk about greenhouse gas emissions from residential building and circular economy mitigation strategies. And if Val also joins us, then we'll have his presentation at the end as well. So the idea is that every one of you has about, well, if we're just 3 people, then we don't have to be that strict on time, but the original idea is that everyone has about 8 minutes of presentation time. We will have 2 minutes for direct questions. That means that, of course, everyone here on the panel can ask questions, but you can also ask questions if you're an attendee through the WRF app. And Frederico, I think, will help me then in facilitating these Q&As. And then we'll, after these 2 minutes of direct questions, we will move to the next speaker. And at the end, we have enough time for a joint discussion on our topic of this special session. All right, then I would invite Benjamin McLellan as the first speaker on supply chain justice consideration for new energy vehicles. Ben, the floor is yours.
Hey, so thank you for the introduction. I'm Ben McLellan, Kilter University, and so I'll be talking roughly on this topic of supply chain justice considerations for new energy vehicles. And next slide, thank you. So, and you can probably, if you can click on 1 or 2 more, I think there are a couple of animations in this. But so basically, I'm going to be focusing on today this important shift that we have to make in terms of reducing the obviously reducing global greenhouse gas emissions. Then it's very important to reduce the emissions in the transportation sector. And the transportation sector, of course, comes along with not just greenhouse gas emissions, but as we burn diesel and petroleum products, we also create a lot of other pollutants. But and so well, there are a number of different technologies that we can use in addition to things like cycling, walking, or potentially various forms of public transport. Of course, one of the largest solutions that we have is moving to things like electric vehicles. Federico, if you could click on again. So we have a couple of different potential shifts. If we're trying to move, obviously, if we're trying to move to from gasoline vehicles to electric vehicles, that's one shift which will reduce direct greenhouse gas emissions. But in order to overall have a positive impact, then, or a move to zero emissions, then we have to also shift the electricity that we provide for those electric vehicles, or the energy that's input if we're using things like hydrogen vehicles. And in this, we have to think about the idea of a just transition. So how is it that we're affecting people across the entire supply chain? Next slide, please. And so just to look at a couple of so I just want to show you an example, just a quick example with some of the results of looking at particularly at emissions, though. If we look at the emissions, so up in the top right-hand corner, you can see the selected emissions. So I've just chosen greenhouse gas emissions and also some of the sort of the typical local emissions, local air pollutants, particulate matter and volatile organics and NOx. And we can see the total sectoral input impacts there, basically showing electricity is quite a high impact in Australia, largely because it's based on a lot of coal and also some gas. But the transportation sector is also quite a large contributor to greenhouse gas and also to those localized emissions. In the transportation sector, it's passenger vehicles, which are around about 50% of greenhouse gas emissions, as you can see on the bottom left hand and the graph on the bottom right. Whereas some of the other emissions are more dominated by commercial vehicles and trucks. In Australia, that's one of the reasons that is true is because passenger vehicles tend to use a lot of gasoline, normal petroleum rather than diesel, which is used by trucks. Sorry, if we can go next slide, please. And so one thing we can look at is what happens if we reduce emissions or if we switch to 100% EVs in the passenger sector, which is good for the global environment. Then what will this do in terms of the local environment? And so we can see on the right-hand side, basically, if we switch all of the vehicles, the passenger vehicles in each of the states of Australia, to their local grid electricity, what will the emissions reduction be? And so we can see that basically in no case is there 100% emissions reduction, because of course all of the states of Australia have some fossil emissions in the grid. And if we look at the left-hand side and on the bottom, we can see a comparison with other emissions. So CO2 is the one which is reduced the most. And if we look at the grid as a whole, then there will still be a large proportion of emissions for particulate matter, NOx, and volatile organics. If we could switch to the next slide, please. So, but I don't want to just focus on the electricity grid, because it's obviously there are multiple aspects of this transition, and when we want to look at the idea of a just transition, I think Australia is a very interesting example. Although it's a very highly developed country, we have a lot of obviously a lot of extractive industries. And so when it comes to the idea of a just transition and sort of identifying who's going to be impacted and to what extent, then we have to think about, particularly in Australia, well, what's going to be offset downstream, or well, downstream or upstream. And so in the case of Australia, then we have a lot of mining. If we actually want to move to zero emissions, we have to move away from mining coal, although mining coal in Australia is about 75% or more is actually exported. But if we were to say that we're going to shut down mining coal, then that will obviously have some good impacts for the people who live around coal mines, in that they won't get as much, potentially won't get as much impact in terms of emissions, but they'll also lose their jobs. And there'll be likely to be an economic downturn. And so, but on the other hand, you have places which will be expanding the mining of lithium, cobalt, and other critical minerals which are required for producing things like the batteries and the motors in electric vehicles. And therefore, there will be other places that benefit. In terms of the supply chain benefits, I think it's important that we're actually trying to think about the whole of the supply chain and where and who is benefiting and who is being impacted on the whole by in different ways. If we could flip to the next slide. I might just very briefly mention this, but basically, if we want to look at again, one of the pieces of work that we've done has been looking at if we want to make the most equitable or hopefully the most just transition, then what is what would be the best power stations to shut down? And if we're shutting down coal-fired power stations, can we replace them with renewable energy? And in the case of Australia, basically most parts of Australia would be able to be reduced, would be able to replace any coal-fired power stations with fairly well equivalent sized PV power stations. There's a lot of land, but actually the best places to be replaced, both in terms of cost and in terms of equity, end up being basically the dirty coal-fired power stations, or anywhere that we can replace a power station with wind rather than PV, just in terms of cost and also in terms of jobs. I think the next is my last slide. Sorry, many animations. This is basically just a summary, and I apologize if I haven't presented it very well. It's late at night, and I'll use that as an excuse. But basically, in terms of our zero carbon transitions, there are obviously indirect and direct impacts. Basically, in terms of mobility, we need to think about where the energy comes from and where the materials come from, but also where the emissions will be transferred to, or effectively transferred to, if we think about shifting from gasoline vehicles to electric vehicles, or to other clean energy vehicles. Because at the moment, again, if we take the example of Australia, if we switch to electric vehicles, it just means that the people who are living around coal-fired power stations still get the same emissions, the same pollutants, and the emissions are not particularly entirely offset. There are many other aspects about a just energy transition that we'd need to think about, like, can people afford electric vehicles, and which parts of the community will actually benefit, but I'm not going to talk too much about that today. Anyway, thank you very much. Questions welcome later on.
Thank you very much, Ben. Thanks for also keeping the time. I will, first of all, before we go into brief questions, say that now, thanks to solving the technical issues, my co-chair Kei Jing is now also here. Thanks for joining us, and I see that we have the second speaker, Veronica, as well, joining. That's very good. Glad that you are all here now. All right, let's, before we go into the next one, questions and direct comments to hear Benjamin's presentation. Willem.
Yeah, maybe. Thanks a lot for these interesting insights and the perspective, Benjamin. One short question in terms of the value chain, the complete supply chain, as you mentioned. Australia is, of course, very advantaged, so to say, because they have a lot of mining stuff in the ground, a lot of natural resources that can be used for the energy transition worldwide. So the mining can be done locally, but as you probably know, a lot of the stuff that comes out of the mines in Australia is processed in China, where it's more difficult to control. So if you talk about the social justice side of things, we have to look at the whole chain. Have you already investigated that?
No, and but it's a very important point. I've mostly so far been looking at basically both extremes of the supply chain, if you like. So the customer or consumer side, and the at the other end of the extraction of the resources. But you're very you're very right in that for Australia and for many extractive-based countries, the resources are, exported, and then everything manufactured is imported back into the country, which is certainly from the Australian perspective is one of those. It's a disadvantage. It's also vulnerability in the supply chain. But as you mentioned, particularly relying on China as manufacturer of basically everything. Equally, really from the Australian perspective, is relying on basically all the rest of the world in terms of actually manufactured goods. And try as the governments and subsequent governments may, they fairly well fail to get manufacturing to come back to the country. So yeah, that's a difficult part, but certainly something needing investigation. And I'm not quite sure how to deal with that middle part of the supply chain.
Thanks.
Thank you.
Great, thank you very much. Thanks for the question, and thanks, Ben, for answering that. I would say then we'll move on, because we have time for discussion later on, to the second presentation, and the second presenter will be Veronica Kiss. Okay. Veronica, you ready for the presentation? We cannot quite hear you. You're unmuted in Zoom, but it seems to be very low volume. Not quite.
Maybe you have to move your microphone.
Yeah, it is better.
There we go.
Okay.
Yes.
Thanks. So are you going to share the slides?
Yes.
Yeah, thanks a lot. So good afternoon or night for everyone. And I am just, I am Veronica Kiss, and I am representing a small consultancy firm based in Hungary called Green Formation. And can you move to the first slide,
yes,
please?
Try to do it yourself, Veronica. Now I could solve the...
Okay.
Yes, please. It doesn't work.
No.
I'm giving you the control of the screen. I don't know. Doesn't work. Okay, I'll go on then.
Okay, thanks. So yes, and I am going to talk about energy use caps and under scrutiny. And can you go to the next slide, please? So I am representing a small consultancy firm based in Budapest, striving for green social and economic transformation. We focus on different areas, but my main topic is about sufficient energy use and socio-economic transition and transformation. For this, we carry out research, but also we provide advice and advocacy at different international policy levels. Please, to the next slide. And why we have to really limit our energy use. I think that you are mostly familiar with these graphs. On the left-hand side, you can see the graph delivered by Stockholm Resilience Center is about the 9 identified planetary boundaries. Out of the 9, already 8 have been measured, and out of these 8 measured planetary boundaries, we can see that 5 have been trespassed by humanity activities, and only 1 is focusing or related to climate change, and we really have to modify our focus, and not only focusing on decarbonization, but also on dematerialization. And on the right side of the slide, you can see the donut model, because this limitation should be really delivered in a socially just manner. And in the donut, in the inner circle, there are different kinds of social foundation which really should be met in order to deliver social enhancement for all. This includes energy, health, security, and so on. And in the middle, I put it in a little bit bigger, that it is the merge of the two graphs, and what we should aim for as humanity, to stay within the green circle and eliminate all the red color on the graph, because the red color represents either ecological overshoot or social foundations which haven't been met. So please go to the next slide. So for this, we have to limit resource use, and because resources are required to invest in sustainable infrastructure in the future as well, but also resources are required to improve the standard of the living of the world's poor. If we have to choose, we need to choose capping energy use first, because it is the most overarching resource, and its limitation would impact the use of other resources as well. And at the same time, it would reduce energy independency while increasing geopolitical stability. And bringing the social justice aspect to this issue, for instance, bringing the world's population, which represents approximately 13% of the global population who lacks electricity, wouldn't cost more than 1% of CO2 emission global budget. So it wouldn't take us so far if we ensure proper access to electricity for those who really need. Please go to the next slide. And based on this issues, I focused on how energy use caps can be implemented in a socially just manner, and I experienced that energy use capping schemes mostly based on equal per capita distributional mechanism, and I questioned whether this kind of distributional mechanism would really ensure social enhancement of those who really needs the social enhancement. And based on this, I examined justice theories, and based on three justice-related concepts: the distributional justice, procedural, and recognitional justice. And I analyze Hungarian household energy use patterns, and I use different kinds of methodology, including quantitative and qualitative methods. Please go to the next slide, which contains already the results of my research. I identified 4 clusters within the Hungarian households based on their heating resources. And these 4 clusters are households using mostly piped gas for their heating. The second cluster contains households using mostly central heating. The third one, households using mostly solid fuels to satisfy proper temperature, and the fourth one contains those households which use the mixture of gas and electricity. And I identified that those households using mostly solid fuel live under the worst living and dwelling conditions, while pay more on energy from the total housing cost than the households from the other 3 clusters. But at the same time, they consume slightly more energy than the Hungarian average. So if an energy capping scheme based on equal per capita energy quota distribution is implemented in Hungary, it wouldn't benefit these households. Please go to the next slide. And my further results show that the poor and marginalized are more often exposed to pollution and environmental problems, and also left out from opportunities, not only, for instance, investing in energy efficiency investments to improve or to reduce their households' energy cost, but also jobs because they require higher educational level. And due to these circumstances, there they have bad dwelling and equipment condition, which cause further burden to pay for energy-related cost, and through this, they are getting more deeply into energy poverty, which hurt their capabilities. And please go to my last slide, I suppose, which contains the conclusion. If we think of energy use caps implementation, we should deliver like sustainable energy use in a socially just manner. We have to really consider distributional justice in a way that social justice and dwelling condition are considered in the distributional mechanisms of this kind of schemes. In terms of procedural justice, we need to ensure that access to proper information on opportunities and jobs are ensured. And also, in terms of recognition justice, these schemes should enhance social acceptance of the poor. For instance, trying to shifting from the current consumption-based economic model to a new alternative one. For instance, enhancing caring for others and for nature. And last but not least, these type of schemes should mitigate illegal energy resource use, which is a very, very abundant phenomenon in Hungary. And for this, proper data collection should be realized to reveal the underlying causes of energy use. And my last slide is about just thank you for your attention, and I'm looking forward to any question.
Thank you very much, Veronica, for this presentation. We'll also have quick, direct questions to the presentation for this one.
Christos, I'm not seeing any questions on the WhatsApp, but I also opened the chat here in Zoom for any, in the case of any participant wants to.
Okay, that's also good. Yeah, thanks.
A bit more comfortable.
So I would have then, we'll take the opportunity here, Veronica, to have one specific question. So you're talking about energy caps. Is there any idea at which quantity this would happen? Were we talking of something that would just that would be envisioned just for a few people, or would it be a widespread energy cap? Can you say something about this?
Yeah, I investigated two concrete proposals. One was developed in Hungary back in 2009, and the other one in the UK almost in the same period. And both of the proposals were on the table of the National Parliament, but they weren't accepted. And both of them would focus on national energy use cap. I mean, they envisage that the current level of national energy use would be kept, and it would be lowered year by year constantly until it reaches the carrying capacity of the concerned country or the concerned territory. And within this cap, households would represent one sector, but the other sectors, namely industry and governmental related sectors, would receive a concrete amount of quotas. And because the household sector was investigated more deeply, I investigated these energy, like the energy use caps focusing on households. And within this set cap for the households, those who overconsume should either reduce, either invest, or either buy quotas from those who underconsume. This is, in a nutshell, the explanation of this very complex system.
Thank you very much. Thank you very much. All right, then I would say we'll move over to a joint discussion. So because we have now 4 presentations, we'll do the 2 slots actually as initially planned. So we'll have a joint discussion on the 2 presentations by Benjamin as well as Veronica. So we had 2 presentations talking about equity and distribution issues. Benjamin, more on the question of regional discrepancies. So one technology disproportionately harming one area of one country, for example, rather than another one, and technological shifts moving these environmental impacts then in a regional scale. And Veronica was talking about this idea of energy caps and what this would do with the national economy and the various distribution problems that are occurring during this process. So what kind of questions or comments do we have from the round of panelists and of course also from attendees joining us? Door is open. Willem, I see. Yeah, go ahead.
Happy to start. Not with a specific question or a specific remark, just an observation about the complexity of the issue. And I think those 2 presentations showed it very nicely. On one hand, looking from a national perspective, primarily, and Australia as an example that is taken. And based on your question, Christoph, also about the energy caps, yes, at the national level, that's doable in principle to talk about it. Governments do talk about it, but what does it mean for individual people? As Veronica showed very clearly, that becomes very complicated. And I think we have a similar complexity when we talk about individual companies, for example, and what it means. So it's rather easy to set top-down targets, especially when we think about science-based targets top-down for a region, for a country, or for a specific industry. But it becomes very tough to set targets at an individual company or individual family level. That's what I think was very nicely illustrated by those 2 presentations.
Thank you for this observation. Other observations or comments or questions? Oh, we do have one from. Oh yeah, go ahead, Kay, and then we will have afterwards. We will have one from Gordana in the chat. Go ahead, Kay.
Yep, thank you. First of all, I would thank both presenters. Actually, they're very informative on the presentation and shed a light on this different initiatives and developments. So my question is for Benjamin. I came a bit late, but I still captured the the second part of your talk. But you mentioned about a zero carbon transition. When actually the challenges that are facing, if they actually move towards the renewables, because they heavily rely on those critical minerals, whether actually, I'd like to actually ask you that to your view about zero emission, whether actually zero carbon, whether the scope of the definition of the zero carbon seems very much focused on the operational side, where actually the embodied carbon hasn't been really well addressed, and most of this zero carbon transition the policies and the various programs. So come to actually the mining aspect. Could you please share a bit more of the your view on how actually we can better define the zero carbon transition?
Thank you. That's a big question. Sorry. So I think you're right in that. I mean, the focus on zero emissions is often, like you say, in the operational side. Obviously, if you take a sort of an ideal view, if everybody in every part of the world, in every industry, in every operation is zero carbon, then it's all zero carbon. So, and that's in their operational phase of every industry. So that's the sort of one theoretical ideal way of maybe looking at it. But that's without thinking about any carbon leakage across borders or outer systems. I think at the moment, obviously we have a system which is reliant on, in many parts of it, on heavily on fossil fuels. And so how do we get to that, reducing that embodied impact, I guess, is in part, well, apart from being very challenging, if we wanted to look at it very seriously, it would be looking at trying to source from countries with the lowest countries, or actually supply chains with the lowest carbon emissions. We actually did a little bit of work on this about 10 years ago, maybe, but looking at what you could do with, particularly with minerals. So at the moment, if we were to, and one of the reasons sort of links into the question from Gordana about or Jordana, I apologize if you got your name wrong. But the basically the idea of what do we do about the supply chain, and could we effectively could we manufacture in Australia? And if we were going to manufacture in Australia with the current grid electricity, then we'd be a fairly dirty producer of everything. Of course, you know, it being done in China at the moment, China is equally quite a dirty producer of everything, given the grid energy mix. But if we were to export all of our ore, we could basically export more or less all of our ore over to places like Iceland or Norway, or maybe Canada, to somewhere that has a better electricity and a better energy mix, which could improve the supply chain. But then economically, it's not the best thing to do. And of course, in terms of volume, it probably wouldn't work out. But even if we consider the transportation emissions, still exporting it to somewhere, again, basically exporting it across the other side of the world, we could still potentially reduce the emissions rather than, well, more than producing it in Australia with the current electricity mix, or energy mix, I should say. So it's a big supply chain problem, I guess, an area for life cycle assessment, but also an area for looking at, I mean, it really comes down to specific supply chains, I think, which is maybe the difficulty is we're looking at global emissions, but very specific supply chains and being able to compare them with a level of data which we don't really, I don't think we've got that level of data at the moment available to us.
So I see, Ben, that this was already your answer to the question of Gordana. Is decoupling from China and the development of the whole value chain on the Australian agenda? This is already your answer to that?
Well, I think there's a strong, well, it's part of that answer. Sorry, there is
then please go ahead.
There is a political agenda to try to, yeah, well, there's always, but there has been for a long time in Australia, as Kishing, I think we would well know as well, but there's been a long-term desire to get more manufacturing back into Australia after we let all manufacturing go overseas in the last 25 years or so, in particular, with basically because it costs too much to manufacture stuff in Australia. So it's always on the agenda, but it's usually it loses out because of cost, like many things.
Thank you very much. I think we have time for one more question or comment that's coming from the group.
Hi.
Yes, Daniel, go ahead.
Yeah, thank you for both presentations. They're very appealing with the work that we are doing at McGill, trying to find this indirect impact that usually we cannot see or measure. So maybe we can collaborate or on this some ideas. For example, in this idea, this concept of justice, because social justice, environmental justice is very intangible, right? So I don't know if you could elaborate some ideas both and how this justice could be quantitatively examined or measured, if you have some initial ideas, because for us this is the hardest part. Even using these tools like life cycle assessment or the social life cycle evaluation is hard to do it. And my second question could be related to the implication of this just transition. What are the implications like upstream and downstream? Because again, this is the other part that is hard to measure, as William was mentioning, is somehow easy, not easy, but you can make the big numbers, but how to put it and what people and what ecosystem will be affected. So this is kind of my comments and questions to you, both of you.
Veronica, would you like to start?
Yes, thank you. So in related my research on Hungarian households, I identified approximately 20 justice-related variables from the already existing Eurostat database using the EU Silk database, because it contained more usable, from my view, more usable variables than the Eurostat survey on household budget survey. Yes, but I identified based on my conclusion that there are like lacking data or information in relation to measure household conditions and how it relates to the well-being of those who living there. So I concluded that further data or further data collection would be needed in order to create those variables which would really measure, or through the changes of which we can measure social enhancement of those who need the most. So based on your question, I can share what I collected, like 20 approximate 20 variables and concrete suggestions where we need further data, but not, so we really need more data on this.
Thank you. If you can share that, will be amazing. Thank you.
All right, thank you very much. I think we'll leave it at that.
Could I make it, Christopher? Could we use 1 more minute?
If it's very short, yes.
Very short. I'll keep it short because I always like practical examples. So I recently had a discussion at an event about hydrogen for the heavy industry. So in Germany, I'm based in Germany, talking with the steel industry, where they of course need a lot of energy to melt the steel. So the smelterij, so to say. And then the discussion is we have to transfer that, or the industry has to transfer to hydrogen to use that in the smelter process. And then the question is, where do we get the green hydrogen from? Well, basically, where do we get the green energy to produce the green hydrogen? And that's not in Germany. That's, for example, in Colombia, across the ocean. And then the question comes up, so where should we have then the factory? So the smelterij, should we have that still in Germany and transport green hydrogen from Colombia to Germany? Of course, what the German government would like and what the German employers would like to have, because it stabilizes the employment in Germany. Or should we actually build the factory in Colombia where you have cheap green energy and transport just the half production in the steel to Germany and do the final production? Of course, then the unions are saying, well, we will lose a lot of jobs in Germany, but we create a lot of jobs and economic development in Colombia. And at the same time, in Germany, we need a lot of people to actually install solar panels on the roofs of the houses to stimulate that. So it actually would be good to train people that are now working in the steel factory to install solar panels. So I'm just taking this as a practical example how complex the discussion is, but also why it's important to take a worldwide approach.
Yeah, thank you, Willem, for this practical perspective. Summing up also this first discussion point that we had for the first two presentations, slot number 1, and with that I'm giving it over to introduce the other speakers to Kay. Please take over.
Thank you, Chris. So now let's move to the second slot. Since William, you've been talking, so now it's your turn.
Okay.
So we'll move to your presentation. So William Bathius, so that from the Better Building Initiative, so that over to you, please.
Thank you very much. Okay. Yeah, Federico, if you could share the slides. And if okay, I just ask you to move to the next slide to keep it technically as easy as possible.
Yes, I will try to give you the control this time.
Yeah, I just have a few slides. I'll ask
Perfect.
you if that's okay with you.
Okay.
To make it technically as less complicated as possible. Yeah, thank you very much for the opportunity to talk a bit about the Better Building Initiative. This is not coming from a research institute, from people that are coming from a more practical background. So not a lot of scientific research behind it, but looking at how can we drive and catalyze the sustainable transformation of the construction industry. If we move to the next slide, please. Why do we need to do that? Well, first of all, the world needs construction. The world population needs shelter, needs infrastructure, and in a lot of developing regions, even more so than we, but even in Germany, we need a lot of updates of the infrastructure. So construction is an essential industry in the whole world, and actually growing in importance in a lot of cases because the population is rising. At the same time, the construction industry is responsible for about 40% of all materials extracted. And if you just think about sand is in volume the most scarce resource in the world, especially construction sand. That's we tend to forget it, but sand is in volume the most limited material that we need actually to build those constructions. Without the sand, we can't build. 40% of materials extracted, 35% approximately of waste generated, 30% of gas house generated, of which 15%, so half of that is used actually for the building materials. So the construction industry has an enormous impact on the sustainability, and we're not even talking here about the social aspect that can be aligned with it. So we have to go through a transformation in this industry as soon as possible, but we have a couple of challenges in that. Next slide, please. First of all, on the left side here, we see a couple of typical characteristics of the construction industry, which makes it difficult to go through this transformation. There's a very limited history of innovation. The construction industry hasn't really done anything to increase its productivity for the last 50 years compared to other industries. So there's not so much innovation happening traditionally in the construction industry. There is a lot of risk aversion because those buildings or those bridges have to stay there for 50 or for 100 years. So you don't like to take risks with new materials. There's a high degree of regulation, and usually the regulation is, of course, lacking the innovation. So before we could build high-rise buildings in wood, it took many years because wood was not allowed to build high-rise buildings. High degree of fragmentation in industry, which makes transformation very difficult. Very many small players and very high cost competitiveness. So all kinds of reasons why the construction industry is a difficult one to transform. At the same time, and that's what we are focusing on with the Better Building Initiative, on the right side, we look at a couple of sustainable transformation success factors, as we call them. What makes success possible in transforming such an industry as the construction industry to become substantially more sustainable? First of all, that is, we need intrinsic motivation of the management and the employees of the companies. It doesn't help to set just top-down targets. We have to make sure that the organization, the individual companies, even if it is a 20-person company, that the company is motivated, the people are motivated to make a transition, because that's hard work to transform your industry. We also have to operationalize concepts like the triple bottom line performance goals, not just financial bottom line, but also ecological and social bottom lines. That requires, in most cases, a redefinition of your business model, which is one of the most difficult things to do if you have a company that runs well, to change the business model. You have to collaborate with ecosystem partners. You can't do it alone, and especially you have to also embrace innovations from third parties, from startups, from universities, because they drive the innovation, usually not the established companies. So those are success factors that we have to make sure that we address if we want to change the construction industry. And as mentioned already, we need all the ecosystem partners, and we have illustrated them here in the middle. All the different parties that you need to have involved to change the construction industry is the users of the building, is the builders, of course, but it's also the architects, the regulators, the scientists, the investors, and the ventures. Next slide, please. And so we looked at what are shortcomings of standard transformation approaches to transform such an industry. And one of the things is that the standard approach is to focus on top-down standards target setting. So science-based targets, regulations, and things like that, as we talked about before. But those are very external. They're very abstract for an individual company and the employees of a company. So it's very difficult to drive and to motivate people intrinsically, also the management of companies, to change dramatically by setting science-based targets. They're abstract numbers that are very relevant for the world, but not relevant for my company. Same with absolute targets. So a lot of the target setting is focused, first of all, on CO2, and then on CO2 tons reduction, for example. Well, that creates the problem in the whole industry, in a lot of industries, that we have to define and agree on how to measure how many CO2 tons we produce, and how we measure that and how we report it. So there is a whole industry by now that is only focusing on how to measure and how to report CO2. But that doesn't reduce the amount of CO2 by anything. So we are taking a slightly different approach, not focusing on absolute targets, but on relative targets, which I come back to. Long-term targets is another issue. If you talk about what should we do as a company in 2030, or even as a country in 2045, then basically I can just continue my business as I'm doing today. And by the time I retire, my successors will have to work on this. So that doesn't help. And as I mentioned already, a lot is focused on CO2 at the moment. So single parameter focus, which means that I might optimize my business on CO2, but therefore I use more water, or I create more pollution, and maybe I create more waste or more social impact, etc., etc. We have to look at all the factors because they are all related to each other. And last but not least, if we focus on my company only, and especially the scope 1 and scope 2 impact in the CO2 perspective, for example, I move the problem to my suppliers or to my customers or to the end of life phase. So those are a couple of key limitations of a lot of current approaches that we have seen in the construction industry, for example, that makes it very difficult. So let's move to the next slide and look at what we believe are solutions and what we are promoting as the Better Building Initiative. First of all, bottom-up target setting, company specific. For my company, I set my targets. I define them myself. They're not coming from a government or from a world organization. I set my targets specifically for my company. So I'm motivated to work on realizing those targets. Second thing, I'm focusing on relative targets. I'm not worried about whether I measure exactly the same as other companies or as the world says I should be measuring. I'm measuring in my way, and as long as I measure this year the same as next year, I can see how much reduction I realized. So it's a relative improvement target. Short-term incremental targets, which can be embedded in the normal incentive systems that we have in those companies that define the bonus of the people at the end. So they can see immediate results, they're motivated, they even see it in the pocket if they realize the targets. Holistic approach, all sustainability aspects, as I mentioned before, not picking on one and then getting worse on the others, but looking at all of them and making sure that if I improve on one, I don't get worse on the other aspects. And last but not least, the ecosystem focus, which of course is very important, essential if you talk about circularity. I can't do that with my own company. I have to work with my supply chain, with my customers, with the whole ecosystem around it. So those are the 5 principles for the Better Building Initiative. Next slide, please. And to make it a bit more concrete, we said, let's make a better building manifesto, as we call it. We said there's a manifesto, and we ask organizations, and especially companies, to endorse this manifesto. And endorsement just means we like it, we believe in it, we think it's a good thing. Just not more than that. But that's already a first step, an endorsement. Second step is a commitment to target setting. So there we say, you as a company, as an individual company, you select 2 of the targets that we have listed here at the bottom, the 12 targets, areas, and you commit to improve on 2 of those 12, 10% per year, without getting worse on the other 10. And that's the trick. You can select which ones you want to improve on, which ones you want to focus on. 10% improvement on the way you measure it, as long as you don't get worse on the other 10 aspects. And then the third aspect is, of course, to actually drive this transformation process and make sure that you realize those targets without getting worse on the others. It's a totally different approach as a science-based target approach. Both are needed, but for an individual company, we believe, based on our experience also in the industry, that this is the right approach to stimulate companies and the management and the employees. Next slide, please. So we are organizing as Better Building Initiative a number of actions to help this, to act as a catalyst. There are a lot of initiatives, a lot of very good initiatives. We don't want to replace them, we just want to speed things up. And one of the aspects that we are driving is Innovation Venture Summits. So we are organizing, for example, here in Lausanne in October, together with one of the biggest venture capital organizations, a dedicated venture event for the sustainable construction and infrastructure industry, where we give the opportunity for startups and scale-ups to meet investors, but also to meet the big industry players, the big cement producers, et cetera, to make sure that the innovations from those small startups are actually adopted and also financed by the venture capital industry. We advise key stakeholders. We create inspirational activities because we believe if people get inspired, they get motivated to also implement things in their own company. We organize matchmaking events where we match specific innovations with specific companies where it makes sense. And we are working on creating a matchmaking platform where it is possible to find, to allocate the most suitable sustainable building materials or building methods for your specific building projects. And we do that with support of a couple of students from the Entrepreneurship Masterclass at the Technical University of Munich. Last slide, please. Thank you. So we said it has to be based on voluntary, and that's also an approach which is different, of course, than standards and regulations and government guidelines. We say we want to work together with organizations, with companies specifically, that are self-motivated to make an impact on the sustainability of the construction industry. So we say you can become a friend of the BBI, you can be a contributor, actively contributing, bringing in ideas, bringing in innovations, et cetera, Better still, become an endorser of the manifesto. So really commit to improve on a couple of points, as discussed before, or you can become a sponsor. That's basically, in a nutshell, our approach that we are recommending and that we developed over the last years by working a lot in this industry. And if you want to support or join us or have questions, of course, you can write us at the email address here or go to the LinkedIn site to help us catalyze this sustainable transformation of the construction industry. Thank you.
Thank you, William. So we will have time for a quick question. Just with it. Anyone that any question regarding the William's presentation and any comments? Yeah. Okay, Chris, please.
Yeah, one question, Willem. So you criticize the top-down targets like science-based targets, and you say that combination of bottom-up relative targets and short-term goals will be more efficient. How do you make sure that the goals that the companies set themselves are appropriate to match the planetary boundaries that we are faced with, and that they are, so to speak, ambitious enough?
Valid question. Over time, we believe that those two will come together automatically, more or less. The most important thing that we have been focusing on to get companies to work on improvements. Because one of the things that we know from a lot of industries, from other transformations, or the digital transformation of industries, from dealing with uncertain situations like the corona, or et cetera, companies have to learn to change, have to learn to go through a transformation process. That's the most important thing. Once companies are getting into a mode of doing that, they will be able to select the right targets. They will be also motivated, also financially probably, with CO2 prices, et cetera, to do the right thing. But the most important thing is, what we focus on, at least at the Better Building Initiative, is to enable companies to start making transformation processes. And then I would almost say, but this is a bit provocative, it doesn't really matter what the first targets are that they pick. as long as they start to get into the transformation mode.
Thank you. Maybe if we have any further questions and comments, we can move to when we move to the panel discussion. So let's move on to the next presentation. So the presentation will be done by Daniel Rondinel. So he actually will talk about how we further improve our building, reduce the greenhouse gas emissions. Over to you, Daniel.
Thank you. I'm wondering if I can share mine because we have a lot of animations. Otherwise, you can share the video. I don't know which is better. Can I share mine?
Yes, just a minute, please.
Okay, thank you. Okay, give me 1 second here. Okay, can you see? Yes, perfect, thank you. I'm going to present with Alejandra Acevedo. We were part of a big team, so maybe Alejandra, you can start. Please.
Yes, I can start. Thank you very much for your attention. I am Alejandra Acevedo, and with Daniel, who is my colleague, we are going to present the research Carbon Footprint of Housing, a study of circular strategies in the Global North and the Global South, developed in collaboration with Dr. Naomi Kina. This study is part of a major research project from the UN Environment Programme that involves the efforts of researchers from the Yale Center of Ecosystem in Architecture, the McGill University, the University of Lima, and the UC Louvain University.
So this study applies a life cycle assessment approach to 2 case studies located in Montreal and Lima, as 2 cities that offer a global north-south view of the challenges, opportunities, and potential levers faced in achieving the decarbonization of the housing sector.
In the global north, the demand will be mainly in relation to renovation, and this is the case for Canada, while in the global south, it will respond primarily to the construction of the new buildings, and we can see this in Lima. Statistic Canada reported that 62% of the Canadian homeowners planned a home renovation. In addition, 20 to 30% of Canada's solid waste comes from construction, renovation, and demolition. In relation to Peru, in the last 60 years, Lima has grown from 1.2 million to 10 million inhabitants, and currently has a deficit of more than 612,000 housing units. This demand for housing increases the need for new building materials, and there is an extensive use of reinforced concrete for mass housing, which results in high embodied carbon emissions and tons of waste at the end of life cycle.
The conventional linear economy model of demolishing and landfilling has proven to be inefficient, and the accumulation of construction, renovation, and demolition waste represents a global challenge. In the building sector, the proportion of construction waste that ends in landfill is still alarmingly high, and only 20% of worldwide construction waste is recycled or reused. There is a huge potential in reusing and recycling these discarded building materials.
So to investigate the potential benefits of a shift to a more circular economy approach, 2 different alternatives to landfilling are considered in this study for the end-of-life phase of the buildings. Mainly reuse, which includes selective deconstruction and recycling.
The research examines 2 distinct housing typologies, a housing unit in a triplex building in Montreal, Canada, and an apartment housing unit in Lima, Peru.
For Montreal, the triplex is the representative of a typical Montreal housing unit. Apartments make up to 58.4% of the Montreal dwellings, and on the other hand, 94% of the new formal housing units in Lima are apartments.
The traditional Montreal triplex housing has a timber frame construction and brick facade. Consists in 3 apartments with 4 members. In the case of Lima, an apartment has a reinforced concrete structure, a brick facade, and hosts 4 residents. In the pies, we can see the main material used for each case. In Montreal, there is more variety, including concrete, brick, veneer, or wood. But in Lima, The concrete is by far the most predominant, and then steel and brick. The goal of the study is to understand the life cycle impact associated with 3 scenarios of the end of life of the material in each housing case. The 3 scenarios are scenario 1 is landfill, the scenario 2 is recycling, and the third is selective deconstruction. Here we can see the 3 scenarios.
As mentioned, we modeled and test 2 typical housing units, the Montreal triplex and the Lima formal apartment building. The building aspects considered in the representative model are structure, space plan, and scheme. Note that the use phase was excluded from the scope of this study because the focus was on materials and assemblies rather than energy demand of the house. Then we create a hypothetical representative average dwelling for each city. The data used for creating the model comes from archetype studies, local analysis, architectural surveys, and census data previously identified. With this data, a 3D model was elaborated using a building information modeling system. And for each housing type, a bill of material was calculated. Then an LCA was carried using EcoInvent and Gavi LCA software. The LCA includes from cradle to grave phases, sourcing, manufacturing, construction, and end of life. The defined function was to provide shelter and comfortable housing to people. Consistently, the functional unit was set in both cases as 1 average housing unit accommodating 4 persons. 3 end-of-life scenarios were considered and modeled, aiming of highlighting the potential benefits of reusing and or recycling some of the building materials or complete assemblies. First, the selective deconstruction, allowing reuse and recycling were applicable. Second, recycling, and third, landfill. Finally, possible impacts results for each scenarios were obtained from the LCA software.
The potential reduction in greenhouse emission by using selective deconstruction as opposed to landfill is 63% in the case of Montreal and 70% in the case of Lima. And in the case of recycling as an alternative to landfill, the emission reduction are around 48% for Montreal and 50% for Lima. This is valid for the carbon emission, but also for water and fossil resources that were also analyzed on the study. Consequently, same tendency was noticed for water and fossil resources, and it's possible to affirm that diverting material at the end of life will reduce significantly the environmental impact of housing, and for instance, could be between 29 and 48% of water in the case of Lima, or in the case of fossil resource could achieve saving between 29 and 69%.
In terms of end-of-life allocations, the avoid and burden approach was used consistently for all scenarios. This approach is best suited to highlighting the benefits of recycling by assigning impact credits to the recycled materials, assuming that this will go on to displace equivalent quantities of their primary counterparts. This assumption cannot be made in the case of all materials, as some are downcycling. Therefore, a quality ratio was added to the calculation of the environmental credits. In relation to the recyclability and reusability index for different materials, the study shows that some materials such as aluminum and steel have high recycling factor and are highly recyclable, both in Montreal and Lima. Some materials such as concrete has a low recycling factor, and reused concrete is still problematic in the reuse scenario. Only 10% of the concrete is reused. However, in the scenario 2, 100% of the concrete is recycled. The technological viability and recycling outputs of materials are critical factors in determining the environmental impacts of housing.
As conclusion of the study, first, circular economy is instrumental. A circular economy practice like selective deconstruction and recycling can lead to significant reduction in environmental impact of housing materials, such as up to 70% decrease in greenhouse gases emission and 67% decrease in water use.
Second, there are material impact disparities. Housing materials used in different regions have varying environmental impacts. The technological viability for recycling or reusing materials range from high value as aluminum or steel, simple to divert as wood or bricks, complex to divert as asphalt or glass, and with limited option as paint and some types of insulation.
There are challenges with material recycling. For recycling of material the recycling of material can sometimes have counterproductive effects. For example, converting a structural lumber into secondary engineered parts might require more energy and material compared to using virgin wood. Synthetic resins add for recycling further limit consequent recycling.
Also, early design choices have repercussion on the ability to reuse or recycle materials later on, and applying reduce by design principle as designed for disassembly during early design stages is crucial for facilitating reuse and recycling. While reusable elements offer benefits, challenges related to technical, social, legal factors, and a lack of frameworks must be addressed.
Finally, it's necessary to create new policies and standards, nurturing reuse markets, establishing quality standards for secondary materials, and addressing restrictive regulation are key for sustainable material practice. Future studies should examine broader scales, including urban or global housing stock.
Thank you.
Thank you. Thank you, Daniel. Thank you, Alejandra. So both, you have done a very well with the joint presentation. Now we have a time for quick questions before we move on to the panel discussion. So, is there any question from the audience?
I think there's
maybe
one
I
question
could-
in the chat, actually, from
There's
Gunnar.
exactly, there's some questions on the chat.
So, the question for Alejandra and Daniel, did you address the element of longevity? I reckon that's the longevity of the building and the building components when you compare to different types of housing.
Yeah, regarding that, we were using the approach that we are supposing the possibility of two life cycle for each material. So in the case of I think that the question is more related to maintenance. So I don't know if you need to change window or whatever. We are not considering that. We are having the bill of materials of each model, and with that we are doing all the model because we like in the formal house, at least in Lima, and in the case of Montreal, it's always formal. The amount of change that you will have of materials, I'm not talking about maintenance, only materials, is really low. So we assume that that model is the one that we are doing. So no, longevity is more related with two life cycle possibilities of each material, and we are not considering the change of, I don't know, if something is break. I don't know, Alejandra, something else?
No, I was just thinking about this concerning the longevity of materials. If we think of the informal housing in Lima, we are now doing another study trying to implement the same methodology in informal housing, because in Peru we have more than 60% of the dwellings that are constructed in an informal way. And there we are considering, in that study, we are considering the stages of consolidation of the dwellings of the house. And yes, this is really important to consider the time and the different stages of the house.
Yeah, so in that study that we are developing now, we started with the easiest part, that was the formal for Lima and Montreal. But in the case of the informal, we are having this kind of backpack of material that we are using through all the life cycle of the building, of the house. So in that case, we are considering.
Okay, great. Maybe we can, since we now start, we finished all the presentations and all four presenters have given a wonderful talk. Now we can actually start the panel discussion, so we can actually revisit any part of the four presentations, particularly the last two, because if actually any comments and further questions, or now you can even ask questions. You can see that the questions that you raised and also being addressed in the chat. That's word William. William, can you please share with us your answers, because the question is about how to avoid the greenwash in the construction industries.
Very valid question, and of course, greenwashing is the last thing we want, because that will turn basically off all motivation of the people that really want to change. So very relevant question, a bit also related to the question of Christoph earlier. How do you make sure that you can actually that you're working as an individual company of targets that are relevant also for the top-down targets, so to say, the science-based targets, for example. But also, and I think that was the question here partially also of Cordana, how can you make sure that you can aggregate data from individual companies to see how far we get as a society on improvement? So my answer to that was basically we need both things at the same time. So I'm not against science-based targets. On the contrary, we need them. But science-based targets and top-down targets and standardized-based reporting is not necessarily motivating individual companies or people at companies to make changes to start the transformation process. So we need to do both, but the companies that, of course, then will start an internal transformation process, they still are obliged to do formal reporting according to standardized measurements. And that reporting can be aggregated, and therefore we can see whether the industry or the country in total is making the right progress in the right direction. We need both, the top-down and the bottom-up, the standard methods and the specific methods for a specific company. That's our view.
Thank you. Now, Chris, you have your hand up, so you've got a question.
Yeah, thank you. I think my question is to Daniel mostly. When we say we want to design a product so that it is more recyclable, very often we have OEMs in mind who make the decisions. But in the construction sector, there's much more stakeholders, right? I mean, there's not just one person designing a house with all its components and designing it to be very well recyclable in the end. There's the architect who has his vision of the building. There's maybe the family that wants to live there at some point and wants it to be affordable, the house. There's a lot of regulators who make, and then there's the engineers who have to make this thing possible. And then there's the construction company who actually builds the whole thing in the end. So how do we manage all these stakeholder interests, even when each of them has this goal of design for recycling in mind?
Yes, thank you for your question. This is one of the key points, definitely, that we are addressing. As you just mentioned, there are so many and so different interests in the building industry. How to do that? I think that the first that idea that is coming to my mind is that we need to start early in the design. That's one of the key insight that we got from this study and others, because when you start early, the impact will be much higher. So even this idea that the first option is to construct less, right? This is one of the lessons that we learned from this research is that you need to address, as you mentioned, we have like many stakeholders that we can group in, like, I don't know, from extractive design, we can group them in the same way that we are grouping the life cycle phases, or we can understand who is part of each life cycle phase. And then we need to address, in particular, each actor in each phase, and try to have all the possible strategies for each actor in each phase, and then try to make it work, like everything together. But again, for us, like the focus should be in this moment in the design part, because this is the biggest impact. If you design something to disassembly, and I understand that maybe the user will not like to have this design for disassembly, his or her house for disassembly, but again, if you start working on that moment and then you explain the benefits of this, that is an investment, that you can you can sell this part of the house or take out of this part of the house, or this, I don't know, finish of the house, or then I think it could start making a change. But I agree with you that this is the hardest part. One of the hardest part is to try to put all the actors together and make them then to talk between them. Even just one more idea is that there are a lot of actions that are happening independently in each of the phases and each of the actors. But the hard part is to put everything together. Yeah. But I can say that maybe in the first part is important. The first phase. I don't know, Alejandra.
Thank you. Yeah. Oh, sorry,
yeah.
Alejandra.
Yeah. No, just to complement that, this is specifically challenging in South American countries or in the global South because of the system of building. For example, in the formal part of the housing, almost all the constructive system are based on concrete. So trying to think about implementing this design for disassembly, and we have to modify the regulatory frameworks that need to support circular economy practice. And so we need to really interact with the policymakers in Peru. Yes.
Thank you for clarifying further. Thank you. I can see William. You have your hand up.
Yeah, maybe to add a little bit to that, I fully agree with Daniel and Alessandra said. And of course, also in our Better Building initiative, we have a lot of those discussions and also discuss with a lot of startups how they can help to solve this. So we see, roughly speaking, 4 areas in the sense of stimulating reuse, disassembly and reuse, and design for reuse. One is, of course, that you have to have as architect, as builder, as designer, you have to have the right information about what is possible, what is allowed, etc., etc. So digital tools to help that process is one of the criteria, because it's so complicated and the regulations are different in every country, in every city. The weather circumstances are different. So there is not one solution that you can apply for everything. A 2-story building is different than a 10-story building, etc., etc. So we need digital tools to make it easier. Secondly, we need tools that actually can capture what is as reusable material in a building. And there are some companies like, for example, the Dutch startup Madasta that is doing that. So they build databases of what materials are in a building and what can be reused and what is the potential value of it. Because then you can also show basically to the investors what would be possible, because the investors ultimately that invest in the buildings, not an individual family building a house for themselves, but investors of bigger buildings, they start to understand that sustainability has a interesting aspect also from a financing perspective. It's easier and it's cheaper to get money for a sustainable building, at least in parts of the world already, than for non-sustainable buildings. So it's the combination of those factors. And then, of course, in the end, it's the user of the building that wants to, that also should be benefiting from it. So we have to look at ways of combining disassembly potential, but also making the building itself more interesting or more flexible for the users of the building by having removable walls, etc., etc. It can be reused, but also can be moved during the lifetime of the building. So those 4 factors, from our perspective, could contribute to more reusability.
Thank you for your comment, William. So I think that's actually what you mentioned could have been addressed quite well if we our last presenter turn up and give the talk, because they talk about actually provide the service which actually added to the reusability and the circular economy practice. I think that we approach the end of the session. So actually, if I may I just ask one more question just before we finish? Is this question actually for me is to William, and is how actually you benchmark if you promote relative improvement? Can you give a very quick answer to this?
Very good question. Thank you for that. Yeah, I think the idea is that you don't benchmark in terms of absolute numbers, but you benchmark in, do you realize 10% improvement as you promised on 2 aspects without getting worse on the others? If you do that, then you're good. If others can do that, they're just as good. So, but it's not a competition, so to say.
Okay.
You just want to make sure that you start to make improvements, and that's the basic principle behind our approach.
Okay, thank you. All right. So I think that we have completed all 4 wonderful presentations, and very informative discussions and a lot of comments and thought and food for thoughts after sessions. So I would say I really enjoyed the every part of the talk. Chris, over to you. Maybe you want to wrap up the session for us?
Yeah, also from my side, thank you very much to Ben, Veronica, Willem, Daniel, and Alejandra for our presentations and the joint discussions that we had.